Today we are covering 8A, which is solving one-step equations. Our content objective is students will be able to solve one-step equations. Language objective is students will be able to clearly state their reasoning with regard to finding the solution. And why am I learning this? Well, it's important for science problems involving forces acting on an object. So first things first, let's cover some background knowledge. So first is the inverse properties. We've talked about it before. Inverse means opposite or reverse. So essentially when we're trying to solve these equations, we're basically reversing the steps to find out what the value is of the variable. So we're going to be using those inverse properties a lot for solving equations. First, we have the inverse property of addition. Basically, it's when you have two numbers that are the opposite, so a positive and a negative. They're called additive inverses of each other. They equal zero. So basically, we're trying to get zero, and we're trying to isolate a variable at this point. Then we have the inverse property of multiplication. It's basically the reciprocal. So here we have a and 1 over a. These are multiplicative inverses. So notice here, you're making 1. Okay, we're definitely going to be using these properties when we're solving equations. So vocabulary, first is the inverse operations, which are operations that undo each other. Addition and subtraction are inverse operations. So here are some examples. Subtracting 7 and adding 7 are inverse operations. Positive 9 and negative 9 are additive inverses. And again, basically the two numbers add up to 0. Multiplication and division are inverse operations. So some examples are multiplying by 3 and dividing by 3 are inverse operations. So again, you can think of opposite. Divide by 11 and multiply 11 are inverse operations. And then 9 and 1/9 are multiplicative inverses. So again, they're essentially the reciprocal of one another, and they're going to give you a product of 1. So vocabulary basically are the 4 different operation property of equality. Basically, this is going to allow you to do whatever you do to one side, you do to the other to keep your equation balanced. So we're going to be using all 4 of these as we're solving for equations, depending on the problem. So in 6th grade, you first learned how to solve one-step equations. Your solutions were most likely always positive numbers. So now, moving on to 8th grade, the idea behind solving any equation is that you're trying to find the numeric value for the variable to create a true statement. So before, problems were easy that you could probably do it in your head, which is great. Great mental math. But there's going to be some problems, especially in the 8th grade, that you might not be able to do in your head, like negative 12 3/5 equals negative 5 and 7/8 plus t. Do you know the value of t off the top of your head? Probably not. Well, what about negative 18 and 75/100 equals z over 3 and 2/3? Do we know the value of d off the top of our head? Probably not. So what you're going to notice in 8th grade, and you probably experienced in 7th grade already, it's crucial and mandatory that you show your steps when solving equations. And in fact, it's something that you're going to carry on with you even in high school. So we got to make sure we are doing that as we solve equations. Okay, so for this first problem, it says solve the equation below, show all your steps. So here, the first thing I'm going to want to do is isolate x. And the only way to do that is to get rid of this positive 31. So I'm going to go ahead and say that the opposite of adding 31 is to subtract 31. So I'm going to go ahead and subtract 31 from both sides. And that's basically using the subtraction property of equality because I'm doing it to both sides. Here I basically have additive inverses because it equals 0. So now negative 31 plus 31 equals 0. So I'm left with x equals, here there's more negatives, and there's 21 more negatives, so x equals negative 21. Now, not only is it important for you to show your work, it's also going to be important to also check your work. Make sure that your answer is correct. So off to the side, I'm going to go ahead and plug in for x. So here we have x plus 31 equals 10. So instead of x, I'm going to go ahead and plug in a negative 21 and then check to see if that really does give me 10. Well, negative 21 plus 31 is 10. So 10 equals 10. I am 100% sure my answer is correct. And that's all there is to it. So let's go ahead and move on to the next thing. So now there are some rules for transforming equations that we always want to keep in the back of our mind. First of all, our goal is to always get the variable on one side of the equation by itself. And you're going to hear me use the word isolate a lot. It means the same thing. We want it to get it to one side by itself. So again, we're going to use the word isolation. Number two, always perform the same operation to both sides of the equation to keep it balanced. And again, those are the different addition property of equality, subtraction property of equality, because we're going to keep things balanced. You can't just do an operation to one side and create an imbalance there. Number three, to undo an operation, perform its inverse operation to both sides of the equation. So as we're trying to isolate a variable, the way to undo it is by using the inverse. So addition and subtraction are inverses, multiplication and division are inverses, and last but not least, always show all of your steps. Always. That's very important for you to carry even to your high school and to your college years. Showing steps, one way of thinking of it is to make sure we are keeping things balanced. So here, let me give you an example. Here we have a balanced equation. What happens if I subtract 3 to one side? And that's it. What happens is one side basically gets heavier. Okay, so what we need to do in order to keep things balanced is whatever you do to one side, you do to the other. So this is an example of using the subtraction property of equality to keep things balanced. Here, you would end up with x equals 4, but again, it will still be balanced. So algebraically, there's some ways of showing your work, and this might be a method you've seen before where you stack it vertically. Here in 8th grade, and you've seen it in 7th grade, we actually prefer that you write it off horizontally. And this is the reason why we choose to do it this way is you're less likely to make a mistake doing it this way, especially with the negatives and positive integers. So let me give you an example of how you would do that. So first here, what I would do is read the instructions, solve and check the equation below, show all steps. So notice it says solve and check. This is what you're going to be expected to do on your homework, so please make sure you do both of them. So I'm going to go ahead and try to isolate my y off to the left. So I'm going to use the inverse operation. So the inverse operation of subtracting 8 is to add 8 to both sides. And here I created some additive inverses because that creates 0. Okay, so that's the reason why we use additive inverses. Now this, I'm going to go ahead and put 0. So I have y equals here. Do I have more negatives or more positives? I'm going to say I have more negatives. How many more negatives are there? Just a quick side work. I'm going to do 26 minus 8 to compare them. I have, let's see, 18 more negatives. So I'm going to say y equals negative 18. But now, since it does say to check your work, I'm going to go ahead and check my work. On your homework, there is a side specifically set for you to check your work, so you're going to use that. So here, let's check our work. We have y minus 8 equals negative 26. So instead of y, we're going to go ahead and replace that with a negative 18. Notice when I substitute values in, I do use parentheses, so you want to start practicing that and making sure you do the same. Now let's check our work. Here we have negative 26 equals negative 26. My answer is correct. So just a quick review. Here we went ahead and used the inverse operations to isolate the variable, or you could think of it as we're using additive inverses because additive inverses create zeros. So either way, and notice whatever I did to one side, I did to the other. We're keeping that balance with our equations. So you solve your equation and then you need to make sure you check your work. So keep that in the back of your mind. Okay, so let's move on to the next example here. So now you're going to notice it's going to get a little bit more difficult because in 8th grade, we're going to be working with fractions and decimals very often. So what do we do here? Well, I'm just going to go ahead and use the same steps I did before. Here, I'm going to go ahead and try to isolate n. And how do I do that? Well, I'm just going to do the inverse operation. What's the inverse of subtracting 3.5? Would be to add 3.5 to both sides. So again, I'm using the inverse operation, but you could also think of it as additive inverses because additive inverses creates 0. So I'm going to go ahead and eliminate this because it gives me 0. Now notice the reason why we write it horizontally, it's nice because the sign of the number is made very clear. So here off to the side in my side work, very adamant on making sure you use the correct side work and things don't clash with the work that you show down here. So off my side work, I'm going to go ahead and do -4/5 plus, I'm going to go ahead and make this an improper fraction right now. 2 times 3 is 6 plus 1 is 7, so 7/2, where my lowest common denominator is 10. I'm going to go ahead and, let's see, multiply this 5 by 2, multiply this 4 by 2. So -4 times 2 is -8. Now here, I'm going to add 2 times what gives me 10? It would be 5. So multiply the numerator by 5, and I would get 36. So, oops, I mean 35. So here I have more positives. How many more positives? A little bit more side work right here. That would give me 27. So I'm going to say positive 27 because there's more positives than there are negatives. So I'm going to go ahead and write that down. Here I have n equals 27 tenths is my answer. But again, part of the instructions is to check your work. So what I'm going to do here is go ahead and write down the equation real quick. And then instead of putting an n, I'm going to go ahead and substitute my value, which was 27 tenths minus 3.5 equals -4/5. So I'm going to go ahead and check my work. Let's see, this would be 27 tenths minus 7/2 equals -4/5. So here, let's multiply that by 5. So I would end up with 27 minus 35. Does that equal -4/5? Yes, it does. So I'm good. So again, it's very important that you check your work because sometimes we do make errors in our arithmetic and we don't realize it. So checking your work is going to tell you whether or not your answer is correct. Okay, so now moving on, I'm going to go ahead and actually have you pause the video right now and try number 4 on your own. Okay, so now we're back. Let's go ahead and try out this problem real quick. First things first, we're going to isolate our variable, and the way we do that is by using the inverse operation. So here we're adding a -4 32/100, which is essentially what's the inverse of, right here I would call this subtraction. I'm going to go ahead and do the inverse, which is adding. So I'm going to add 4 32/100 to both sides. And again, I like to write it above. It makes the operation very clear. So now this, I created some additive, pair of additive inverses, which becomes 0. And then here, off in my side work, I'm going to go ahead and figure this out. First of all, I have more negatives, so I'm going to mark that right away. I'm going to go ahead and line up my decimals to figure out how many more negatives are than positives. Borrow, 10 minus 2 is 8. Borrow again. We have a 7, we have 5, so it's 5 7/800. And then here, since this is gone, we're left with W equals -5 7/800. We're done. But before we state that this is our final answer, we're supposed to check our work. So I'm going to go ahead and do that and write this down. W plus negative 4 and 32 hundredths equals negative 9 and 1/10. Instead of a W, I'm going to go ahead and plug in my value. Notice I write parentheses as I do that. Then put plus negative 4 and 32 hundredths equals negative 9 and 1/10. Well, let's check. There's definitely, my answer is going to be negative. Let's see how many negatives we have. Some side work real quick. Let's add these up and see what we get. 10, 11. Bring down that decimal. This gives us 10. And something's wrong. So notice here, it doesn't check out. Okay, because here I have negative 10 and 10 hundredths equals negative 9 and 1/10. Something's wrong. Guess what? That means this answer is not correct. So I'm going to go ahead and look back in my work, and I can see where I made a mistake right here. 8 minus 4 is not 5. It is 4. So now let me go back and re-plug that in and see if that helps. I'm going to go ahead and put a negative 4. Ooh, what happened to my pen? Negative 4. And see if that helps. So let's recheck this answer. Okay, so here we have definitely negative. Let's see how many negatives we have. Negative 4 and 78 hundredths, negative 4 and 32 hundredths, 0, 1, that's it. Oh no, carry the 1, sorry. And we have negative 9 and 1/10, because the 0 doesn't matter. And this works. So notice checking your answers definitely helps, especially on a quiz or a test. You know whether or not your answer is right by checking your answer. So this was a prime example of what if I made a little error here? What could you do? Check your answer. See if it's correct. So I wouldn't say that W equals negative 5 and 78 hundredths. I would say W equals, you guessed it, negative 4 and 78 hundredths, because this was a negative, because there's 4 negatives and there are positives. Perfect. Hopefully you didn't make the same mistake I did, because you checked your work and you figured it out. Okay, so now we have another example here. So I know that there's fractions, but please don't let this discourage you. You still would use the same exact steps as before. I'm going to isolate C, and in order to do that, I need to do the inverse operation here. It's minus 2/3. So the inverse operation of subtracting is to add. Here, this creates an additive inverses, which makes 0. But whatever you do to one side, you have to do to the other. So notice I also write things off to the right. I never write things off to the left. Think about how you write words. When you write off to the left. The same applies for math. So here, I'm basically left with C equals. Here, I'm going to have to do some side work to figure that out. So I have negative 5 and 4/5, which in fact, I'm going to go ahead and turn that into an improper fraction right now. That would be negative 29/5 plus 2/3, where my lowest common denominator is 15. I'm going to have to multiply this denominator by 3, this numerator by 3. Let's figure that out. 29 times 3, that's 87. So we have negative 87 plus, you got to multiply this by 5 to make a denominator of 15, leaving you with 10. I have more negatives, and I have 77 more negatives over 15. So here is my final answer. But again, not only do you have to solve, you also need to check your answer. So I'm going to go ahead and check my answer real quick. Now here, I'm just going to go ahead and turn negative 5 and 4/5 into an improper fraction, which is negative 29/5 equals negative 2/3 plus, instead of C, I'm going to write down my negative 77/15. Now we got to figure this out. If my lowest common denominator is 15, I'm going to have to multiply this 3 by 5, this 2 by 5, leaving me with negative 10 plus negative 77. And we're trying to get this to equal negative 29 fifths. Okay, so here this leaves me with negative 87 fifteenths equals negative 29 fifths. Well, let's see. If this really was the answer, this denominator has to be a 5. So let's see what happens if I divide this by 3 to make it a 5. Will that give me the answer? Let's do it. 87 divided by 3. That goes in 2 times. Looking good so far. 27, that goes in 9 times. So that works. Negative 29 fifths will equal negative 29 fifths. So I know for sure my answer is correct. That C is negative 77 fifteenths. Okay, moving on. So now let's go ahead and pause the video. I'm going to have you try this problem on your own. Okay, so now we're back. So let's see if you got the answer right. So first things first, let's isolate our variable. I'm going to do that by doing the inverse operation. Here it's a positive 7 and 54 hundredths, so the inverse would be basically subtracting that. So I'm going to subtract 7 and 54 hundredths. Here I just created an additive inverses, so that means it's 0. I'm going to subtract 7 and 54 hundredths. And again, I always write it off to the right side. So here I'm left with y equals. Here I'm going to have to do some side work to figure that out. My answer is definitely negative. Okay, but how many negatives do I have altogether? Well, let's see. Let's do 16, where the decimal is at the end, and combine that with 7 and 54 hundredths. So one thing real quick is a lot of students often forget where the decimal belongs in a whole number. And the way I like to help my students is to think about a check. If I asked you to write me a check for $16, what would it look like? Hopefully you write down 16.00. So that tells you the decimal belongs in the end. Okay, so just think about it. How would you write that in a dollar amount? So real quick, going back to this problem, let's add how much negatives we would have all together. We would have a total of 23 and 54 hundredths. So my solution is y equals negative 23 and 54 hundredths. But before I can state that, let's check to see if this answer is correct. So I'm going to put 7 and 54 hundredths plus, instead of y, let's plug in our value that we got and put negative 23 and 54 hundredths equals, it's supposed to equal negative 16. Let's figure that out. Well, here, there's definitely more negatives, so I'm going to go ahead and mark that it's going to be negative. I'm going to do some side work and see how many more negatives there are in comparison to the positives. So I'm going to find the difference between the two of these. That's 0, 0. We're going to borrow. That's going to give me 6, 1, but I got to bring down that decimal. So I have negative 16 equals negative 16. Voila! I know for sure my answer is correct, so I can confidently state that the solution to this equation is y equals negative 23 and 54 hundredths. So hopefully that was the answer that you got after you checked your work. Okay. So now we are going into something that looks slightly different, but we're going to do the same. We're going to use the same ideas for those rules that we were talking about, isolating, using inverse operations, and making sure we always show our work, things like that. So here we have 7y equals negative 91. I'm still going to try to isolate my variable. And the way that I do that is by doing the inverse. Here, 7y technically means 7 times y. So the inverse operation would be to divide by 7. Here, I just created multiplicative inverses because basically they're reciprocals and it creates 1. So I'm going to go ahead and mark 1 here. So whatever you do to one side, you do to the other. It's that division property of equality. So I'm left with y equals, well, I don't know what this is off the top of my head, so I'm going to do some side work. I'm going to say First of all, negative divided by a positive is a negative. I personally like to take care of the sign first because if I don't, I often forget because my side work kind of throws me off. So if I were you, I would do the same. Determine the sign first and then do your side work. So I'm going to do 91 divided by 7. Goes in once. Remainder of 2, bring down that 1. That's going to go in 3 times perfectly. So I'm going to say my answer is negative 13. But before I confidently state that that is my solution, let's check our work. Let's go ahead and put 7 instead of a y. Let's go ahead and put a negative 13 in parentheses. And let's check to see if that equals a negative 91. Well, let's see. 13 times 7, that is 1. Carry the 2. That's 9. So negative 91, because a negative times a positive is a negative. It looks like it works, so I can confidently say the solution is y equals negative 13. Perfect. So now we're just going to continue on. Here I'm going to do one more example before I have you try one on your own. Oops, let's get out of that. So now, here, same idea. We're going to isolate that variable, and we do that by using the inverse. So first of all, I'm just going to read this out loud so I can figure out what the inverse operation is going to be. I would read this as x over 3. But not only can you say over 3, fractions mean division. So I could also read this as x divided by 3. So what's the inverse operation of division? Multiplication. So I'm going to go ahead and multiply by 3. So here, this is basically a multiplicative inverse. So this creates 1, but whatever you do to one side, you must do to the other. So I'm going to go ahead and multiply by 3 there, leaving me with 1 times x, which is just x. Negative 4 times 3 is negative 12. But again, before I state whether or not this is really my solution, I'm going to check my work. Instead of x, I'm going to go ahead and plug in a negative 12 divided by 3 equals negative 4. Well, negative 12 divided by 3 is negative 4. Does negative 4 equal negative 4? Correct. So here, the solution is x equals negative 12. That is my answer. Okay, perfect. So now moving on, I'm going to go ahead and have you pause the video and try number 9 on your own. Okay, so now we're back. Let's go ahead and do the work and check to see whether or not you did this problem correctly. So first things first, I'm going to isolate my variable, and the way that I do that is by using the inverse operation. Well, 2 and 4/10 m means 2 and 4/10 times m. So the inverse would be to divide by 2 and 4/10. Basically, this is my multiplicative inverse. It creates 1, which is what I want to do. I'm going to go ahead and do that to the other side. You got to keep things balanced. Basically, I just use the division property of equality. So now this left side is basically has left me with m on its own, which is what I want. But on this side, I need to do some side work. Before I go to my side work, I'm going to determine my sign, because if I don't, I'm going to forget about it. Negative divided by a positive is a negative. So here, let's do the work. We have 3 and 84/100 divided by 2 and 4/10. So real quick, note that your numerator is always going to be your dividend, the number that goes inside, okay? Always, always, always. Now, before we divide, we need to make sure we have whole numbers. So I'm going to go ahead and move my decimal over once to the right. Essentially, that means we're multiplying by 10. I'm going to do the same on the inside. Multiplying it by 10 moves the decimal once over to the right. I'm going to bring my decimal straight up. Can 24 go into 3? Nope, so I'm just going to put an X there. Can 24 go into 38? Yes, once. Let's see what we get here. We have a remainder of 4. Here we have remainder of 14. Carry down the 4. How many times does 24 go into 144? Well, let's see. think it's gonna go in maybe about 4 times. Let's see what that gives me. It's 16, that's 8, that's 9. Definitely think we can do a little bit more. So let's try 24 times 6. 24 times 6 is 24. Carry the 2, that's 12, 14. Perfect. So I'm going to go ahead and put a 6 here, and that goes in 144 times. So that's perfect. So my answer is going to be negative. See, notice I already have my negative sign there. I can't obviously forget it because I wrote it down already. Negative 1 and 6/10. But once more, before I claim that this is my final answer, I need to check my work. So I'm going to go ahead and put negative 3 and 84 hundredths equals 2 and 4/10. And let's go ahead and replace that with my answer of negative 1 and 6/10. So here we have negative 3 and 84 hundredths equals, well, what's a positive times a negative? Definitely a negative. I'm going to have to just check my work real quick. 24, 2 and 4/10 times 1 and 6/10. That's 4, 2, that's 14. 1 times 4 is 4, 1 times 2 is 2. And it works. So I know that my answer is correct. So here I'm going to state that the solution is equals negative 1 and 6/10. So notice here, even though m was on the right side, don't let that bother you. It's okay. M could be on the left or the right. It doesn't matter. You're still going to get the correct solution. Okay, so hopefully you got that right because, again, you checked your work. Checking your work is a guaranteed way to make sure your answer is correct, as long as you're doing the arithmetic correctly. Okay, so let's clear this and move on. Oops, wrong direction. Okay, so now what do we do here? Same idea. So I know fractions tend to intimidate you, but guess what? We're going to do the same exact steps, and that's not going to bother us. So here we have an x that we need to try to isolate. So right now it's 4/5 x, which means 4/5 times x. So what could I do here? Well, what's the opposite of dividing? Sorry, not dividing. What's the opposite of multiplying by 4/5? It would be to divide by 4/5. So here, I'm going to go ahead and put divide by 4/5. 4/5 divided by 4/5 is 1 because those are multiplicative inverses. So I'm going to go ahead and do that the same to the other side to keep things balanced using the division property of inequality. So now, since this has become 1, 1 times x is x. Here, I'm going to go ahead and decide right now what's a negative divided by a positive. It is a negative. Now off in my side work, because I can't figure this off to the top of my head, let's go ahead and do that. Let's convert this into an improper fraction. 2 times 3 is 6, plus 1 is 7/2. Notice I'm ignoring the sign because I already took care of it here. I'm going to go ahead and divide that by 4/5. Since it's division, I'm going to go ahead and keep this first fraction. I'm going to change this to multiplication and then take the reciprocal of this, which will make it 5/4. I'm going to check to see if I can cross cancel. Nope. Can I cross cancel here? Nope. So it's just going to give me 35/8. Let's double check if we can reduce that. Unfortunately, we can't. So I'm going to go ahead and put x equals negative 35/8. But again, before we can confidently say that this is our answer, got to check our work. I'm going to go ahead and write 4/5, but instead of x, I'm going to replace that with a negative 35/8. Check to see if that equals a negative. And again, let's change to improper to save us some time. 2 times 3 is 6, plus 1 is 7. So we're going to put 7/2 here. So let's check. Can we cross cancel? Yes, we can divide by 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. Leaving me with negative 35/10 equals negative 7/2. Now some of you might be thinking to yourself, oh, it doesn't work. But you got to be very careful. Check, can I reduce this? Yes, you can. I'm going to go ahead and divide by 5. So this is going to give me negative 7 over 2 equals negative 7 over 2. Does it work? Yes. So I can confidently say the solution is x equals negative 35/8. So again, what's nice is because I'm asking you to leave your answers improper, it's one less step to worry about. Okay, let's see what's next. Okay, so if you're up for the challenge, go ahead and pause the video right now and try this problem on your own. Otherwise, go ahead and try this problem with me. So here, I know this problem looks a little bit intimidating, but guess what? The steps are exactly the same. Nothing's changed. So if I wanted to isolate d, I want to do the inverse operation. Right now I have d over 1 and 1/2, which essentially means d divided by 1 and 1/2. So what's the inverse of division? It is multiplication. So I'm going to go ahead and multiply both sides by 1 and 1/2. So right now, if it helps you, you could probably put a 1 here. Notice that these will cross cancel, leaving me with just 1. So now I'm going to go ahead and multiply both sides by 1 and 1/2. I'm just left with a d off to my right side. And here, I don't know what this answer is off the top of my head, so I'm going to do side work. But before I do side work, let's decide right now, is my answer negative or positive? It is negative. So let's do 5/9 times, what's 1 and 1/2? 2 times 1 is 2 plus 1 is 3, so I have 3/2. Can I cross cancel? Yes, I can. I can divide both by 3. 3 divided by 1 is 3. 9 divided by 3 is 3. I'm going to multiply straight across. 5 times 1 is 5. 3 times 2 is 6. So my answer is negative 5/6. But before I can confidently say that this is my answer, again, you must check your work. So let's do that. We have negative 5/9 equals, instead of d, let's put our fraction, negative 5/6 divided by 1 and 1/2. But before we put 1 and 1/2, let's just go ahead and convert that into a mixed number. 2 times 1 is 2 plus 1 is 3, so I have 3/2. Now I know this looks a little bit intimidating. It's called a complex fraction. Don't let it, because it's pretty easy. So here I'm going to go ahead and put negative 5/9. I'm going to translate this to negative 5/6 divided by, because again, remember, fractions mean division, divided by 3/2. So I'm going to go ahead and put negative 5/9 equals negative 5/6. I'm going to change this division to multiplication. Then I got to take the reciprocal of the second fraction, leaving me with 2/3. Can I cross cancel? Yes. Between 2 and 6, you can divide by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. It's going to leave me with negative 5/9 equals negative 5/9. My answer checks out. So I can say the solution is d equals negative 5/6. And I am done. Okay, so we're on to our last examples. So we're going to follow the same steps. First things first, we're going to isolate our variable, which is a w. The way that I do that is by using the inverse operation. Here we have 3w, which means 3 times w. So the inverse operation of multiplication is division. So let's go ahead and divide both sides by 3. Here we created multiplicative inverses. 3 divided by 3 is 1. I'm going to go ahead and divide the other side by 3. Again, here we're using the division property of inequality. Now we're left with 1 times w, which is just w, and 0 divided by 3 is 0. But before I claim that this is truly my answer, I'm going to have to check my work because that's what it states in the instructions here. I'm going to go ahead and put 3, but instead of a w, I'm going to plug in a 0. Notice again I use parentheses to do that. And let's see, 3 times 0 is 0. Does 0 equal 0? Yes, so I can confidently say the solution is W equals 0. Now, moving over to number 17. So here, for our last problem, we have 0W equals 3. I'm going to do the same steps as I normally do. I'm going to isolate W, and the way I do that is by using the inverse operation. Here we have 0 times W, so the inverse would be to divide by 0 to both sides. 0 divided by 0 is 1, so I'm left with W equals 3 divided by 0 is 0, or so we think. You'll see what I mean in a second. So now, what am I going to do? Before I can confidently say this is my answer, I got to check my work. So let's put 0 instead of a W. Let's plug in a 0 because that's my answer. Let's check to see if it equals 3. Well, 0 times 0 is 0. Does 0 equal 3? No, it does not. So why didn't this work? It looks like I did everything correctly. Well, here, if you look back at our original problem, think of it. Is there any way you can multiply something times 0 to give you any other number than 0? No. So here, you'll realize, if you think about it, there is no such number for W to make this a true statement. So my answer for this is there is no solution. Okay, because there's no value for W that would make this statement true. So that concludes our lesson. Thank you for tuning in. Hopefully this has helped you review some fractions and decimals as well as solving one-step equations. Okay, thank you. Bye.